I'm not sure how long ago it was now, maybe a couple months ago, whenever Velocity was, Gonzalo and I were hanging out, and he said, you know what I really want you to do a talk on is like JavaScript architecture and like how you make stuff so that it keeps working and doesn't break. And this is where that talk came from. And I'm going to apologize up front. This one is a little bit more of theory than the talks that I usually give. So I've tried to intermix some code, but I don't have a lot of code to look at. So to make up for that, I put in a lot of pictures. So I hope you guys don't mind that. A little bit of background on me. Yeah, so as Gonzalo said, work on the homepage. I'm also a contributor to YUI, testing library, profiler, cookie I wrote, and I've done a few books and wrote a chapter for Steve Souter's Even Faster websites. All great stuff that you should go out and buy. Why is that funny? So what I really want to talk to you about is JavaScript application architecture. And when people think about architecture, they usually start by thinking about a whiteboard with a bunch of boxes on it. And so I thought I would be remiss if I didn't start out with that as well. But usually the boxes, well, in most cases, the boxes represent things that you actually end up building. And so what I want to talk to you about building is actually an application framework for your JavaScript. And so I like to think of an application framework as a lot like a playground. Like there's a bunch of different stuff that's going on a playground. You know, you have your swings and your slide, all kinds of different things that are somewhat related, but not necessarily related to each other. Like they're related in their final purpose, right? You go there to relax and hang out and have fun, but the slide and the swings don't necessarily know what the other is doing. And I think that's a really good metaphor to talk about good architecture in general. And so a lot of people stop at this point and say, wait, like, isn't that what JavaScript libraries do? Like there's a bunch of stuff out there and you just get to use it. But JavaScript libraries are more like a toolbox. Right? They provide a bunch of stuff for you to build things with. So you could build a playground, or maybe you could build a car, or maybe you could build a building. Those tools are there for you to use to continue building. That's not where you should stop. And so what we're really talking about as we're beginning this architecture is the base JavaScript library is the very bottom lowest level. And then on top of it, you have the application core that's actually going to run the app. And we'll get a little bit more into that. But first I want to talk about a little thing I like to call module theory. And module theory basically says everything is a module. Like anything that's out there, anything that can possibly be defined, can be defined as a module. And so if we're talking about module definition, this is actually the dictionary definition of module. Some of these don't really fit. The one that I find most interesting is number 4, which is an independently operable unit is part of the total structure of a space vehicle. And I think that's great. I think that's exactly what we're doing, right? We're building this space age stuff, and you want to get it into a bunch of little pieces. And so when you have the International Space Station out there in orbit, I told you there were pictures. Jeez. It's really, really interesting. It's this massive thing that's just floating around in space. And how they get it up there anyways, it's huge and clearly not very aerodynamic. So if you were just going to shoot that thing up there, it would blow up pretty quickly. So what they did is they separated it into a bunch of smaller modules. And each of the modules is built separately, built so that it would interlock with other ones. And each module is pretty self-contained. Right? If you chop off any one of these, everything else continues to work. So I thought this was a pretty interesting metaphor for how to build things. Like if you can take this modular approach with something as complex as International Space Station, it might just have a chance to work on your web application. Not sure, but we'll see. So this is the question, is how does it apply to web applications? And so I like to think of this definition of a web application module very similar. We're talking about an independent unit of functionality on the page. And sometimes that's easy to locate, and sometimes it's not. So I'm going to start with a place where it's easy to locate, and that's on my Yahoo. So how many my Yahoo users do we have? Nice. Excellent. And so you're probably used to this concept, right? Of you have all of these little modules on your page that are each doing something different. And they're pretty easy to identify because they have boxes around them, right? There they are. Very easy. They're all doing different things. But you can actually go one step further and take a look at the header and say, you know what? I bet that I could break that down into a bunch of smaller modules as well. And so maybe it looks something like this. I don't know, it could. Part of the debate is exactly, what part is an independent module and what parts are interrelated. So I don't want to get too deep into why I think this is how it should be separated. But as you're going through and thinking about various web applications that you're working on or use, try and think, like, okay, what exactly is the functionality of this piece of the page and how much of the rest of the page is related? So web application modules, in general, consist of HTML, CSS, and JavaScript, and all within one part of the page. And when you think of it that way, if you're just working on the HTML and the CSS and the JavaScript of that small part of the page, massive problems become much simpler. So one of the key concepts is that any of these modules should be able to live on its own. So if I take weather and I plop it out, I should be able to just put it onto an empty page and have it work. And the reason why that should work is because it's all self-contained, right? There's nothing about weather that knows that it's on my Yahoo. It doesn't matter. It should just continue to work so long as it has its HTML, its CSS, and its JavaScript. And so that's one of the goals of creating scalable JavaScript application architecture. So loose coupling is really, really important in this. Is you want to make sure that there aren't artificial dependencies between your modules, which tends to happen a lot in web development. You really have to keep an eye out for them because tight coupling is your enemy. Loose coupling is your friend. And so in order to enforce this, you have each module with its own sort of sandbox. I'm not talking about sandbox in like the strict security sense that we usually think of it. This is more of a convention of a sandbox, where people just say, okay, I know that I'm supposed to stay within the bounds. Kind of like a little kid. There's nothing preventing that little kid from getting up out of the sandbox and leaving, except for the fear of getting caught by the parent that's standing by. So again, taking a look at the architecture that we have thus far, the sandbox actually sits on top of the application core because you don't want modules interacting directly with the core. So the modules kind of exist on the periphery. Right? What they interface with is the sandbox, and that is their view into the world. So these are the four basic parts of the architecture we're going to talk about. So let's start out with the modules. So modules have limited knowledge of what's going on the page. Right? Each module knows about the sandbox, but it doesn't know about any of the other modules that are on the page. And that's really important. So this is just some sample code, presuming how you might register a module. And I have nothing that actually runs behind this, so if anybody's going to ask me for sample code afterwards, it doesn't exist. It's just on this slide. But the basic idea is that you want to register your module somehow with the core to let it know that it's there. And as part of that registration, you make available this sandbox object. And so in this case, I'm saying I want to pass in a function, and then the sandbox object is passed in as an argument. And then from that, an object can be created using that sandbox. And when it's returned, that can be used by the core in order to run that module. So which parts actually know about the web application being built out of that whole stack? None of them do. Each of those parts is like a puzzle piece. Right? It really doesn't matter if each puzzle piece knows what the whole picture is. It just has to do its job, and that's all. And so exactly what is the module's job? Well, it depends on the module, of course. So weather module's job is to tell you about the weather. Stock module is to tell you about the stock market. So each module's job really is to create a meaningful user experience within its boundaries. That's what it's supposed to do. And then the web application is created when everything is doing its job. Like the entirety of my Yahoo is created when all of the modules on its page are doing its job. And the entirety of the home page is created when all of its modules is doing its job. And in this case, Hello Kitty is created when the puzzle is put together. Really? There's no laughs for that at all? Okay. This doesn't mean that modules can do whatever they want in order to do their job. Definitely not. I like to think of modules as kids, that you need to give them guidelines so that they don't get into trouble. And since most web developers are like kids, that goes double for them. So some of the rules that modules need to abide by are actually similar to little kids' rules. So first, hands to yourself. Only call your own methods or those on the sandbox. You shouldn't be touching anything that you don't have permission to touch. Don't access DOM elements outside of your box. Same thing. You have no need to do that. Everything that you need should be contained within one box, and you just touch everything that's in there. Don't access non-native global objects. Hopefully there's none floating around, but you should definitely not be worrying about global objects, because that creates a really strict dependency on where that module can live. You have to make sure that all of those global objects are always available wherever the module can live. That's really fragile. Next, ask, don't take. So if you need anything that you can't get yourself, you need to ask for it. And that's the sandbox's job. So its job is to stand there and wait for you to say, hey, you know what I really need? I need an ice cream. And the sandbox will say, well, let me see if you actually have permission to have this ice cream or not. And if it's right before dinner, then you probably don't. Don't leave your toys lying around. So that's don't create global objects. You're just polluting it for everybody else, and that increases the likelihood that you're going to create some fragile structures. And don't talk to strangers. So you shouldn't be interfacing with any other modules on the page. You don't know them, they don't know you. Regardless of how much candy they offer, just stay away. And modules really just need to stay within their own sandboxes. And sometimes, as a module developer, you'll start to feel cramped and that you don't have enough access. But really, the level of access that you have is enough for you to do your job, and it's also enough to ensure the overall stability of the application. So next part is the sandbox itself. So there it is, sitting there in the middle. The sandbox's job is to ensure a consistent interface to the modules. That's the only thing that the modules know about, so that really has to stay the same. You don't have a lot of flexibility. Hey, I think I went backwards for a second there. The sandbox also acts like a security guard, I said earlier. It knows what the modules are allowed to access and what they're not. So there's a little bit of marshalling going on there. And so here's an example, very simple. So let's say in the init method, you want to check if Yukin has cheeseburger. You need to check that first before you can try to do something. So call it on sandbox, and if you can, you say thank you. Told you, really light on code today. So the sandbox jobs, say consistency, interface has to be very dependable. Security, determine which parts of the framework a module can actually access. Communication, which turns out to be very important. Translating requests that the module will make into core actions. So I know that the module wants to do this, and what does that mean at the core level? Very important to take the time to design the correct sandbox interface, because this just has to stay the same. It has to remain consistent. Of course, you can add new functionality, but you can't remove it, and you can't change existing functionality. So this is where you should actually spend the most amount of architecture design time, is figuring out this interface. Because eventually you're going to have a ton of modules, and you don't want to have to go back and touch a ton of modules when things change. So the next part, the application core. This is where we start to get into fun stuff. So the core manages modules. That's its only job. And what does that mean? So the first thing is it tells a module when to start and when to stop. So a lot of times we've fallen into this habit of, okay, so I know on page load I need to do stuff. or DOM content ready, I need to do stuff. And really, if you have everything on the page hooking into those events, you end up with chaos, especially because you're not sure exactly what else is going on or in what order things need to happen in order for them to work properly. So it shouldn't be up to a module to start itself. It's up to the core to say, okay, you now have permission to start. And so that may be on load, it may be before, it may be after. But the core is really the only thing that understands when it's safe for a module to start itself. And on the other end of it, it's also the only one that knows when it's safe for a module to stop itself, whether that be on page unload, or before. So the core's main job is really managing this module lifecycle. When is it okay to start? When is it okay to stop? And so I just have some sample code to walk through about this to show you what a possible implementation of a core might look like. And this is really, really simple, not enough error handling. Just want to throw it out there as a prototype to try to solidify some of these things. So first thing I did was have the register method, which I showed you earlier. So register a module ID and a creator function. And just going to take those and store them for later. So when start is called, first thing it has to do is create an instance. So it calls the creator method and passes in a new instance of this sandbox object that's going to be the module's view into the world. And that instance is stored. And then this init method is called. So clearly we're expecting that there's going to be an init method on the object that's created. There has to be some sort of interface so that the core can work with it. And then stop, we're just going to do the opposite. So if there's an instance, we're going to call destroy, which again, we're assuming that it's there. And then just get rid of the instance altogether. A little bit more. And so probably useful to have a start all and stop all methods that will go through and start everything that's in the system or stop everything that's in the system. So just very simple example of how to do that. Go through, pull out each module ID, and go ahead and start it. Same with stop. And so on your web application, what actually ends up happening is you create a series of lines of module registration. So registering weather module, registering stock module, whatever else happens to be on the page. You end up registering them all, and then at the end, you start all. And start all is really like calling application.init, right? I'm starting everything, getting everything ready, and the application is ready to be used. So application core also manages communication between modules. This is the latest iPhone, in case anybody hasn't seen it. And so a little bit more complex example is Twitter. But it's a good example of why this intermodule communication is necessary. So you can go through Twitter, and you can do the same sort of thing. People noticing themselves up on my Twitter feed. I actually had to filter this before I came in. There were some inappropriate tweets that were showing up. Do a little Photoshop. But you can go through Twitter and go through the exact same process of just finding modules that are on the page. And some of them are really obvious and some of them are not. And again, you can kind of debate whether my breakdown is the right breakdown or not. But just conceptually, you start to look at the page and you start to identify different parts as, okay, this could be its own module. And as you go through, you start to find, okay, so you can break this down pretty logically. But the interesting thing here, as opposed to my Yahoo, is that there's actually interaction between these modules. Right? So you go and post a status, and that ends up showing up in your timeline almost immediately. And then you start to click on the filters over on the right, and those end up affecting the timeline too, because everything is just going back to the server and saying, okay, display some new information in the timeline. But you really don't want these things to have any knowledge of what else is on the page. So this is where this intermediary communication becomes really important. So if you were going to look at traditional web application, it probably would look something like this, where you have a bunch of different objects that represent different parts of the page. hopefully at least got this far. And then each of those refers to others. So you have timeline filter that calls timeline, and then you have status poster, which calls timeline. And then you have timeline that has all this stuff. And the issue here is tight coupling. So if you were to go through and remove timeline, then those other two objects break. Right? They can't work anymore. And it may just be because you're creating a new timeline that does something different or a different visualization. But how do you know how many other parts of the code are referencing timeline that you then need to go back and fix? And how confident are you that you'll be able to catch all of those before you push everything to production? It's very fragile. So what you're really looking at is something a little bit more like this, where each module, again, it doesn't know anything about other modules, but it knows that it's doing something interesting to the web application. And so because it's interesting, it just wants to let people know, hey, I'm doing something. And in this theoretical implementation of a framework, I have a notify method on sandbox object. And that basically says, okay, tell me what this information is, what's going on, and then give me the data that's associated with it. So when the timeline filter changes a filter, it doesn't access the timeline object at all. It just says, hey, look, I'm changing the filter of the timeline. If anybody's interested in the fact that I am changing the filter on the timeline, I'm just letting you know. And the same with the status poster. It's like, hey, I'm just letting you guys know I'm posting a status. If any of you happen to be interested in it, I suggest you do something about it. So this is much looser coupling. And then if you look at the timeline, it just goes in and says, okay, I know a certain number of things that I'm going to be interested in knowing about. And so that's timeline filter change and post status. And so in my makeup implementation here, I have a method called listen, which allows you to set up a notification function whenever one of those things happens. So now nobody is referring to anybody else, but they're still communicating. And they're communicating in such a way that I can move things, change things, remove things, and everything else continues to work. So loose coupling, yay. So if I actually go back in later and remove the timeline for any reason, my status poster and my filters never throw JavaScript errors because they're doing their job. They're letting the rest of the application know that something interesting has happened. The fact that nothing on the application is listening for that and doing something is besides the point. They've already fulfilled their job. They've told people that something is happening. So another important job of the application core is to handle errors and to figure out what the best course of action is. So the cool thing about the core is that it pretty much knows what's going on at any particular point in time. And so it can also figure out exactly what type of error happened and then what the appropriate resolution for that error is. So it knows, hey, this really wasn't all that important and an error happened, so I'm just going to ignore it. Or, oh my God, my status didn't get posted because for some reason I couldn't reach the server. That's really bad. I need to let people know about that. And that's the only part that really understands the context of the errors. So this is a function that basically goes through, and when you create an instance of a module, it instruments each of the methods on that object so that any errors that are coming through are being trapped and then funneled into a log function. So it's a little bit complicated, but the basic algorithm is you go over the instance object that was created, look for functions, and for each of those functions, create a new function that has a try-catch in it, call the original function, and then if any error happens, it goes into the catch, and that goes into your log. Now, log can be anything. Could also just be some generic error handler that you have. But the basic idea is that all of the errors end up getting funneled into the same entry point so that you know what to do. So the modules themselves often don't need to know that an error occurred because it's usually their fault that the error happened. Most of the time, errors like this should be caught before going out, but every once in a while, that doesn't happen. So it's really helpful to be able to recognize them and definitely log them back to the server. So I don't want to go too much into error handling because I actually did an entire talk on this last year. If you want to learn more, this is the talk. It's called Enterprise JavaScript Error Handling that I gave at Ajax Experience last year. And it's up on SlideShare, so you can go and poke through that. But basically, everything that I say to do in that presentation is the job of the application core. That's where all of your error information should go, and that's where a lot of your errors should be handled. So just to review the application core jobs, manage the module lifecycle. So tell it when to start and tell it when to stop. You don't want modules trying to figure that out on their own. Enable the intermodule communication. It's really, really important for loose coupling to make sure that you can add and remove modules whenever you want and not break stuff. General error handling to detect, trap, and report the errors that are in the system. And also to be extensible, because the three things that it's doing that I have listed here are actually not enough for it to be doing. So why not? Good question. Web applications change. And a lot of times you have no idea the way that they're going to evolve. Something that starts out very simple can grow to be something very complex. My favorite example, of course, because I work here, is the Yahoo homepage. Starts out very simple, ends up very complex. And of course, nobody was really writing JavaScript when Yahoo first was launched. But the ideal, is that working? Okay. The ideal is that you should be able to continue growing and changing your web application without changing the underlying infrastructure. And if you make it correctly, it should be able to continue on for years and years. And so you need to plan for extension right from the beginning. You need to, in your architecture, there needs to be extension points, places where you know you can add additional functionality going forward because you don't have all of it right now. And so the really cool thing is that when you build stuff for extension, it can just last forever. And I take the digital camera just explosion as a really good example of that. So the smart manufacturers, when they made their digital cameras, made them so that all of the lenses for their non-digital cameras could still work. Like, how brilliant is that? Consistent interface. You get to upgrade a piece of the architecture and everything else continues to work. You don't need to buy a whole bunch of new lenses. You don't need to buy a whole bunch of new cameras. You can mix and match the stuff that you already had. Just absolutely brilliant architecture. And so when you look at the architecture that we've had thus far, what we really need is extensions to the application core as well. And so what extensions could you possibly want? Error handling, for one. Maybe you want to have an extension that decides how to deal with all of your errors in a consistent way, so that can be swapped out later if you decide to change your mind. Ajax communication. This stuff changes all the time. We're definitely not doing it the same way that we were 2 years ago. New module capabilities. So anything that you think a module should be able to do and isn't able to do, you plug it into the core and make it available through the sandbox, and there you go, instant module upgrade. Any sort of general utilities that you want to make available, could be for anything. There you go. And so I want to focus on Ajax communication for a minute because I think this is really, really important part of the extension of the application core. And so it's really important because Ajax communication comes in a bunch of different flavors. And whatever flavor you're using right now might not be what you want to use later. And so there's usually 3 parts to be concerned about when you're dealing with Ajax communication. Right? There's the request format, which is basically everything that goes over the wire, whether it's a GET, whether it's a POST, and what the format is. The entry point that you're hitting on the server, and then the response format that you get back. And these 3 things, any one of them is likely to change at any given point in time. And so you really want to have your Ajax extension. So I'm going to start out with an Ajax XML extension. just to show you the natural progression that I think most of the web applications have gone through in the past couple of years. So a lot of people started out with Ajax and XML going back and forth. So let's just say, for example, that my request format that I'm starting out with is a GET request, and I'm passing in just query string arguments, and I'm hitting this /Ajax entry point because it's really descriptive. And the response format comes back as some XML structure. And that has a status node in it that should be either OK or error, and then there's a data node that has additional data in it. So basic implementation using low-level Ajax, right? Basic XHR object, you get a lot of code in there, right? So you create a new object and you open, and then you assign your own ready state change. There's a bunch of stuff that happens in there. Check the ready state, and you check the status code, and then you try to parse the response. Hopefully there's no parse error. You go and you pull in the status node, and you want to make sure that the status node indicates that it's also OK. And then you process the data that's in the data node into some format that everything can understand, because you don't want it in XML. And then you pass that into handle success. And if any of that doesn't work, then you want to call handle failure. So a lot of code written there. And this is definitely something that you don't want to see in a lot of places in your JavaScript, right? Because anytime any of this changes, all of that has to change. Very bad. But you say, hey, JavaScript libraries really help us with that, right? It abstracts away a lot of this stuff. Oh, hey, wait a second. That was the wrong seg. So let's go through the rest of these pointers first. So entry point, request format, response format, there. Hey, JavaScript libraries help us with this, right? It abstracts away a lot of the stuff that we worry about. So yeah, OK, it looks a little bit better. This is using YUI 3. So we call y.io. That's cool. We got still got the entry point in there. It's all right. It's all right. We have success and failure, which is helpful because we don't need to worry about checking for ready state 4, and we don't need to worry about checking for status 200 or 304. So that helps. We remove that step. But we still have some redundancy there because both success and failure have to call handle failure in case something goes wrong. So if the response format is incorrect, or if the server just says, hey, I did something wrong, like, oh, crap, OK. So this is still a little bit messy. So we still have the entry point. We still have knowledge of the request format. And we still have knowledge of the response format. And as an added bonus, we have a reference to the library that you're being used. So this is actually more tightly coupled than the other one, because now you're relying on a library to be there. So what do you actually want to do? What I actually want to do is, for my module code, I want it to be like this. I just want to say, I want to make a request. Here's the data that I'm sending, my names and my values. And then when this succeeds, let me know. And if it fails, let me know. And so in this case, the data that's coming in is already formatted in the format that you expect. Success is only called if ready state 4 was hit, status 200 or 304 is hit, the response format is parsed correctly, and the status node says OK. Anything other than that, failure is called. Because module doesn't really care why something failed. Right? It just knows I asked for something, and I was expecting something back, and I didn't get it. And that's all it cares about. So this is very loosely coupled. You notice that we have none of those three things. Right? We're not worrying about request format, we're not worrying about entry point, and we're not worrying about response format. So the Ajax extension encapsulates all three of these. And that means any of these can change without forcing modules to change. So now I'm going to change, because it's 2009, to a JSON response, but I also need to change my entry point because somebody said they didn't like /Ajax. And that's OK. Because I can just plop in the Ajax JSON extension into my framework, and everything continues to work. And it works because the modules had no idea about any of those three parts. It still is using the exact same interface that it was before, and we just swap stuff out underneath. So the jobs of the Ajax extension: hide all of those details. Modules don't need to know any of it. It's really irrelevant to what they're trying to accomplish. Provide a common request interface. So that basically means hey, name-value pairs that I'm going to send in, and it doesn't need to know anything about the actual format of that. Common response interface. So you don't really want to take exactly what was passed back by the server and hand it to the module, because that might change. So you want to have some good intermediary format that you know handles all of your capabilities. And manage server failures. Again, modules don't care why they didn't get what they were asking for, just that they didn't get it. So now move on to the base library, which is the part that most people seem to be most familiar with. Base library, at the very bottom of the stack, provides basic functionality. Pretty simple. So there's a bunch of things that you can use as a base library out there. For this architecture, it really doesn't matter all that much. Just pick one and go with it. But the problem that you need to try to avoid is that most web applications end up being too tightly coupled to those base libraries. And I think that's partly because we as developers get really emotionally attached to our base libraries. Like if I love YUI, I love YUI, and if you're telling me I can't use YUI, I don't like you very much. And hence this picture. And I'm here to tell you to release that emotional attachment to your base library. It's not doing all of the job for you, and you actually have enough knowledge to do a lot of stuff without it. There was an interesting presentation a couple of years ago at OSCON done by Joseph Smar from Plaxo. He later came to Yahoo to give the same talk. And he had this one slide that at the time I remember people getting very upset about. And now I find it really, really funny, so I thought that I would drag it back out. And basically what he said towards the bottom, his second big bullet point, was to minimize your dependency on third-party library code. So your base libraries. Lots of extra code comes along that you don't need. Of course, he was primarily worried about performance in this case. Libraries solve more general problems. Use it like scaffolding. And I thought that that was a really great metaphor. That's exactly what it should do, is you use it like scaffolding to get the rest of your architecture up and running. So if anybody's interested in seeing the rest of his presentation, you can go check out his website. He has that up there. Very good talk. But basically, really the only thing that needs to know about the base library is the application core, because it needs to interface directly with that base library. So the reason why that's important is because you don't want to have that dependency on third-party code. So I could start out with my application built on Dojo and decide later on that's not doing it for me, and what I really want to do is switch it to YUI. Now, if the application core is the only thing that knows about the base library, this is completely possible, because you don't need to change anything else in the architecture. As soon as other parts know about the base library, trying to do this swap becomes a lot more painful and a lot more dangerous. So the jobs of the base library, which are very important, browser normalization. So we really want any browser-specific logic to be in that base library layer. The rest of the application should never have to worry about it. So general purpose utilities, you know those, add class, remove class, all of that fun stuff. Of course, CSS query selectors. Parsers and serializers, object manipulation, DOM manipulation, AJAX communication, all the stuff that makes your life easy in general. And then provide low-level extensibility. So when you're choosing your base library, you need to make sure that you can write extensions for it as well. So really, your architecture ends up looking like this, where you have a core in the middle of things that you rely on, and then a bunch of extension points around the outside, so that you can continue to grow your application in whatever way that you want to. Let's talk a little bit about knowledge within the architecture, because I've thrown this around a lot. And I just want to give a summation of this to make sure that everybody understands what parts know about what other parts. So total architecture. only the base library knows which browser is being used. And it needs to know that because it needs to do the browser normalization. And so if you come across a time when you need something else to know about the browser being used, the correct point to extend is actually the base library. You don't want anything above that layer knowing about the browser. So only the application core knows which base library is being used. And that's really important. These two end up being tied together. And the application core's job is really to abstract that base library away. And so only the sandbox on top of the application core knows which application core is being used. You actually can swap out an application core pretty easily. And you may need to recode the sandbox a little bit, but the sandbox interface always remains the same, so it doesn't matter to the modules that are using it. The modules know nothing except the sandbox exists. They also don't know about each other. And no part of this architecture knows about the web application as a whole. Remember, they're just individual pieces that are each doing their own little job. And so the advantages of this, you can create multiple different applications using the same architecture. Take it nobody's picking up on the metaphor on this one. Right, you can use the same base, you use the same core, you use the same sandbox. But to create a different application, you just provide different extensions and you provide different modules. And so you can create a My Yahoo and a Yahoo homepage on the exact same architecture, because the only difference is the extensions pretty much. Everything else remains the same. Really big bonus is that when you separate these into independent units of functionality, you can also test them separately, because you know that they don't have a whole bunch of side effects on different things, and you know that they're not dependent on a bunch of things in the environment that you couldn't possibly predict. So you can actually set up unit testing a lot easier this way than you can traditionally. You just take each individual component, stick it into an area where you start poking it and telling it to start and stop and do its various jobs, and then verify that that's working. And then if you can verify that each part is doing its job, you eventually verify that the web application is doing its job, much like an assembly line at a pastry shop. Knew there was a word missing there. And basically, if you think of it like Jenga, scalable JavaScript architecture allows you to remove any block and the tower still stays. Doesn't matter if it's at the top, doesn't matter if it's at the bottom. Everything still continues to work. And so that means you spend less time worrying about maintaining a bunch of code and more time really being able to be effective creating new features, testing things, and even creating entirely new web applications. And so that is that. Any questions? Yeah, so the question was the naming of module, because coming from a Python background, he thinks of it more as a namespace. And does anybody want to make fun of him for that?
In Ruby,
Yeah.
it's different too.
Yeah, so this is a general problem that I think we've run into, is because widget, to me, means something that is reusable in a number of different modules. So I look at a menu component as a widget, and a module as the weather module that uses that widget. And I think we run into this a lot in computer science, whether it's a widget or a module or a component or a part or a stub or an extension or a plugin. And I think whatever makes it make the most sense to you, feel free to call it. I found that module has worked pretty well, and that was coming from my Yahoo and later working on the homepage, where everybody was already calling it modules. So that's what we kind of adopted, and everybody kind of understands. And there's people in the room that I work with. Does anybody find module confusing in the context that we use it? Besides Oliver, because that doesn't count? Okay. Yep, interesting question. So question was, talked a lot about functionality. But what about data and who owns it and how does it get passed through? So for that, I'll I guess turn it around with another question is, who needs to know about weather data besides the weather module? I don't know.
It depends on what other modules are doing. If anyone else is dealing with weather data, then they might.
Right, so this is where so I tend to believe that data has some specific owner on the page. So as in the weather example, I think that the weather module owns the weather data for the page. And the way that it can make it available to other places on the page is through that intermodule communication mechanism. But then you get into interesting quandaries of what if somebody else also thinks that they own weather data and they start passing that around, and then where's the source of truth?
Well, so
To answer it, I guess, more succinctly, I think that there typically is a module that's responsible for some specific data. If there's something that is more general, you can end up having that as like application core data and then expose it through Sandbox in some way. Does that make sense? Potentially. Maybe after another beer it'll make more sense. So the question was, is it intentional to create a new instance of Sandbox per module? Yes, that was intentional in this example. But as I said earlier, this is just a very basic, non-optimized sample example. If you find that there is a better way to do it, then by all means do it. I thought that this might be the easier way for people to grasp the concept. I think there are some bonuses to having an individual sandbox for each. You don't have to worry about anything kind of bleeding through or modules like accidentally doing something that they weren't supposed to because some other module is actually allowed to. That makes me feel a little bit more safe. But I think ultimately there are patterns that you could do either, where you have one shared one that you end up passing around, or one unique one for each module that's on the page. So that's actually right, is I am moving the problem around. I'm moving it down and away from where most of the code lives. Because most of the code for your application lives in the modules. Right? And you'd never want to touch those once they're working. You want to ensure that they continue to work. And so you're right, the application core does end up needing to implement some of the things that to abstract what the base library is doing, not necessarily implement. And that's a bonus, because that's what allows you to not be tied to a particular base library. I mean, if you are comfortable saying, I'm going to use this base library forever, then I say go for it and let stuff bleed through as much as you want. If you're not sure, then it's actually worth your time to cover up the base library functionality that you think that you need. And I mean, I would venture to say interacting with the DOM, a lot of times we think of it as really complicated, but usually you're doing relatively simple things, right? I'm adding something, I'm removing something, I'm inserting something. It's more or less it. And everything else is like, add class, remove class, replace class. That stuff is useful too. So what you're really talking about at its core is a very small amount of functionality that you're going to provide an extra layer on so that then you can provide it to the modules. Because remember, the Ajax is completely abstracted away anyways. So you definitely don't need to worry about that. Yeah, it's definitely a concern with third-party modules. But you can provide infrastructure around that such that it works. And there are ways to do it. Probably can't get into it tonight. But the architecture that's here really is the starting point. And you can pretty much make most stuff work. I mean, I've worked with this on enough different types of applications that I'm pretty convinced that no matter what the requirement is, you can figure out a way to make it work. Sometimes you just have to be a little bit more clever than with others. Yeah, the idea is that it always goes down through the layers and always comes back up so that the interface is consistent. And there's not enough information in that individual module such that it can break if stuff underneath swaps out. Yep.
So is it probably true that you're playing with base code and application core all the time for performance reasons to speed things up?
Absolutely. So
you have a lot of versions you're dealing with here.
Yeah, so the question was, you always messing around with base and core in order to speed things up? Absolutely. That's pretty much my job at this point. Yeah, so to sum up, the question was, it seems like some things are more easy to abstract away than other things. And the example was, a YUI data table, which is really complex. Could you possibly abstract that away in such a way that you could actually swap in Dojo or jQuery underneath? Very good question. Yes, definitely there are some things that are more difficult to abstract away. When there are things that are more complicated, usually what I do is look at them and figure out what is my use case for that thing. And what you'll usually find is that you're using only a very small percentage of the actual functionality of that particular widget. Right? You're using it in a very specific way. And so if you start from that, you can usually work backwards into some sort of easy abstraction where you say it's supporting everything that I need to support. And so you don't actually abstract absolutely everything, every event, every method. You end up abstracting just the stuff that you need. And that's a lot easier. And I'm not going to say that it's completely easy because data table I know is very, very complex. And it's also one of those things where if you're comfortable saying, again, if you're comfortable saying, I will hitch my wagon to YUI and I will never turn my back on it, then maybe that's something that you're not going to be that concerned about. If you think that there's any possibility in the future that you're going to change your mind, then I think it's worth putting in a little bit more thought and figuring out what the proper abstractions for you are. Okay, so question was, what happens if you have 6 modules that are all trying to get data? Wouldn't it be better to have them all go separately because of CPU considerations? I think actually that's an argument for why it should go through the core, is because when it goes to the core, when it goes through to the Ajax extension, the Ajax extension has the ability to say, hey, I already have 3 things queued up. Maybe it's not the best idea for me to go off and send another one, and maybe puts a stop to it until the other ones come back and then start again. But if you have everything going off and making their own requests, then you have no way of stopping it or throttling it or filtering it in any way. Good question. So yeah, I guess I'm done. That's me. If you want to contact me after this, if you're not catching me during pizza. That's all. Okay.